A solid shaft of 400 millimeter length and 60 millimeter in diameter is bored for a part of its length to 25 diameter. The shaft is to rotate at 500 rpm with a limiting shear stress of 75 megapascal. Find the maximum power it can transmit and also the length of board section if the angle of twist is uniform. Okay, so this is my numerical. Now, what he basically is saying is, let me open a, yeah. So basically, I have a shaft like this, and part of its length is bored. So there is a boring done. Bore means there is a hole made in the shaft, right? So since this is hidden, I'll show it in that class. So basically, the length is 400. So if you take this length from there to here, right? So this is 400 and he has given this diameter as well as the diameter of this hole to be filled, right? And I have to find this length, right? Let me just dimension this. This is given as 25, I believe. Hole is 25 correct? Right? This length is, I think, 400. This diameter is 60 millimeter, 0. Okay, and let me call this as L, or L we use for length of shaft. I'll call this as A. That is better. Okay, I'll just copy this sketch. So in some numericals, he gives the sketch directly. If not, here it is given in words. Let us try. So this is the diagram for this numerical. Now, what is asked is what is the maximum power? Find the maximum power it can transmit, and also the length of board section if the angle of twist is uniform. Now, first part is pretty easy. We have to find the maximum torque that this shaft can transmit. Now I have two parts in this. One is the hollow section and then there is a solid section. So we have to see what is the maximum torque this hollow shaft can transmit, what is the maximum torque this solid shaft can transmit. The minimum of these two will be used for calculating the power. So where is the equation for torque of solid shaft? I'll copy this. We have the torque transmitted by solid shaft, Ts is equal to pi by 16 tau into ds, that is solid shaft diameter, whole cube. So I'm just substituting the values now. Pi by 16 is constant. Tau is given as 75 megapascal. This is 75. ds ds is solid shaft diameter 60. 60. Now let me just calculate this. 60 cube into 75 into 5 by 6. So this is in Newton mm. So I'll just keep one decimal place. 5 6, or I'll make it 6 Newton mm, and this is equal to, just shift 3 decimals, so 3180.86 or 9 Newton meter. Right, so this is the maximum torque solid part of the shaft can transmit. Now I have to find the maximum torque that can be transmitted by hollow section. So that is given by this expression. I have this sentence also there. Just copy the same thing here to save time. The torque transmitted by hollow shaft is given by Th is equal to pi by 16 tau d raised to 4 minus d raised to 4 by d. If you don't remember these formulas, you can use the torsion equation. T by J is equal to tau by R. Okay. So now let us substitute the values for TH. Let's copy this. This is 75. Okay. D is 60, that is outside diameter. Bore diameter is 25 divided by 60. So let us calculate this. 60 raised to 4 minus 25 raised to 4 is this, by 60 into 75 into 5 by 60. So copy this. Just make this one decimal as 8. So it is pretty close if you see, and this is Newton mm, which is equal to 308. You see here 84.9888, so it will become 99, or I will round it off to 308 5 Newton meter. Why I am doing this in Newton meter? Because for calculating power, I need the torque in Newton meter. Now, which one will we choose? This is 3085. This is 3180. We have to choose the minimum value. The maximum on this shaft is the minimum of TS and TH. That is max is equal to, I have to choose this value, 3085 Newton meter. Okay, now we can calculate the power transmitter. Let me just type it. P sorry, it's just getting stuck in between. P is equal to 2 into pi nt upon 60. Right? Now, what is N here? N is in RPM, so I have to do it by 60. If N is in RPS, then you have to just do 2 pi nt. Now, this is in watts, so I need this in kilowatt. So I will multiply here by 10 raised to 3. Correct? Now I have to just substitute the values into this. So copy this again and put the values. 2 pi n and t value. N is 500 and t is 3085. Okay. This is equal to 3085 into 500 into 2 into 5 by 60,000. So it is 161.53 kilowatt. Right? So this is pretty easy. Now the second part of equation is find the length of board section if the angle of twist is uniform. That is, this length needs to be found. So let us get back here. Let the length board section be A. Okay. Now what we have to do is we will use the torsion equation. We have from torsion equation. What is torsion equation? P by J is equal to C theta by L is equal to tau by R, right? Now in this, see here, the length of board section if the angle of twist is uniform. So I need to consider this part definitely, because angle of twist and length is in this term, and see, these two are different sections, correct? If I use tau by R here, I will not get any answer, because tau by R, tau is shear stress and R is the radius of the shaft. So this is of not use. This one we can use T and J, because the torque is different in both the shafts and polar moment of inertia is also different. So we will be using T by J is equal to C theta by L. Okay, I'll just remove this part. T by J is equal to C theta by L. Now let um, theta 1 and theta 2 be the angle of twist for hollow and solid shaft. Okay. Now let us find this individually. Now what is theta 1? From this, I'll just rewrite this, or theta is equal to, now theta remains here, this L goes that side in the numerator and C comes to the denominator, right? So I have T by C, right? See, the torque and the modulus of rigidity, they are constant for that particular shaft. So T by C is a constant into, I'll just put into, now this goes there and the numerator, so it is L by G. So T by C into L by G. Uh, we have theta 1. So theta 1 is equal to T by C into, now this L by J, I have to put the value, so I'll call this as L1 by J1. Okay. Now what is L1? L1 is length of what I have taken. Theta 1 is hollow, right? So this will be A and this will be J of hollow shaft. So this is equal to PA by C J1. Put a dot there to separate this, right? Now let me call this as 1. Also, I'll just copy this expression again, because it is more or less same. So theta 2 here is equal to T by C L2 by J2, right? And this is not A, The length is 400. So I will write it as 400 minus A by J2. Okay, and I'll call this as equation 2. Now uh, J1 and J2. J1 is hollow, so is equal to, I'm directly putting the values now. Now let me write the equation. Yes, pi by 32 into uh, this is hollow, right? And this is bracket d raised to 4 minus d raised to 4. Yeah, that's it. There is no d right. Pi by 32 d raised to 4 minus d raised to 4. Now let us put the values in this. D here is 60 and small d is 25. So 60 raised to 4 minus 25 raised to 4 is into pi by 30. Just copy this. See, these are all in millimeters, so no need to take too many decimals. Just take one decimal. That is more than enough. So millimeter raised to 4. Correct? And just copy this equation and I'll modify that. J2 is equal to pi by 32 into just uh, d raised to 4. So 3 into 60 raised to 4. Let us calculate this. 60 raised to 4 into 5 by 32. So 0 2. So I'll just remove this many mm raised to 4. Okay. Now we have theta 1 is equal to theta 2, or now what is theta 1? Theta 1 is this value, sorry, this value, and this is equal to, right? Now T by C is constant on both side, so they get eliminated, and I just put the value of J in this, or A by J1 is this, is equal to 400 minus A by J2 is this. is equal. And I cannot see here. Can someone try to calculate this? Yes. In this, it will take time. Let me try that. So this will go here, and this will go there. 400 into is this much. Somebody's trying? This side it will be this many A minus of this and here is
Sir, 196.93.
thank you 196.93. Right, you just have to cross multiply and find the value of A in this. In the calculator, it is very easy. In this, it will take time, right? So out of 400 millimeter length, this length is 196.93 or 197 millimeter, right? Is this clear? Any doubts on this?